Alright, so we're going to go ahead and get started here. So today we're going to talk about searching and a little bit about replacement. So in order to do that, hopefully you've seen grep before, you've seen sed before a little bit. But we're going to get into those a little bit more. There's a whole bunch of options I want to cover with grep that are kind of interesting. Then we'll get into sed, and we'll also get into how do we take regular expressions and apply them to these things. So, starting off with grep. Grep is just a tool that you can use to search single files, streams that you pass in from the command line that you pipe in from another command, or actually a number of files. It can go through and search a number of files. That's this recursive option down here, actually. So, let's just get started here. The example that I have is just our SSH config, so remember that. So we're just going to look at this file. So the two ways we could pass data into grep is we could like cat sshd config and then pipe it into grep. Let's say I wanted to search for port or something like that. It would search through that and it would find any words that say port. So looking at grep really quick, this file here is also optional. So if we specify a file here, it will open up that file and it will search through it. So we say grep port sshd config, and it will do the exact same thing. But sometimes we have data that we've been manipulating so far that we want to pass into this, and using that pipe is really nice. Or let's say we have some program output, let's say if config, and we want to search for like Ethernet. So we would only get devices that are Ethernet that contain that word. So going back to this original thing here, we have another option that we can pass, or we have a option, our first option, that's probably the most important. So we're still searching for port in our sshd config, but now we're going to make this match case insensitive. So by default, when grep is searching for port here, that port is going to be required to be all lowercase. If we want a mix of cases, if we want anything to be allowed, we can say -i, and it will give us all occurrences of ports. So as we see here, we had a capital P port, and we had just a lowercase port. So that's insensitive. So by default, grep is only, well, let's see here actually. One of the things we can do, I'm going to test this out here really quick, is specify like all the files in the current directory. So just remember that star expands to all files in the current directory. So if I have multiple files, grep is actually going to say what file that match was in, and then print the match itself. So that's if I'm specifying multiple files. If I wanted to only print the matches, so let's say I wanted to find all occurrences of port and I wanted to store it in a file, just the raw data itself, not the file name and whatnot, I'd want to make sure I remove this, and I can actually do that with this O command. So when I say -O, it would only print the actual data. Oh, never mind. That's what's happening there. So when I say -O, it only prints the actual match itself. So in order to only print the data, I'd say capital H. And I would say lowercase h. Lowercase h. Capital H enforces the name thing. So then that would only print the data, and I could redirect that to a file, and I could say port data. And I would have that in a file, and I could work on it however I wanted to. So here's another interesting one. V is invert match. So let's say I wanted all lines that did not contain port. We'll just start off with that one. We could say grep v port, and then we'll still look at our sshd config, and it will print all lines that don't match that thing. Perhaps a more interesting one would be all lines that don't contain a whatever words you want to use for that character. There's a number of different words you could use. I could say like this, and I'd have to probably escape that because the terminal interprets that as a comment. And now it would print all lines that did not contain a pound sign, I guess we'll say, which is kind of interesting, I guess. So doing that way, we'll talk into how we would actually go about stripping out these comments in a better sort of way. This was kind of heavy-handed, because what this would do is it would find this pound sign on any line, and it would not print that line. So if it found it even inside a command somewhere, it would not print that line. So one of the reasons we need to use regular expressions is because we want to control where that can actually be matched at. So we could also only print file names. So let's say we wanted to print the file names of everything that contained port. And then we could say star again against, let's see here, echo star. Just remember, star expands to all the files in our current directory. And just remember that one. So grep L port star, it would print just the file names of all of the files that contain this information right here. So we could also take grep one step further and put it in recursive mode. So what that will do is it will find any directories, it will find all the files in those directories, and it will search through all of them, and it will show us the data. So we can control it just the same way as before. So let's say we wanted to only find the file names, we could say -L. If we only wanted the data, we could do -H. So let's go over to, let's say etc is a good directory, and we'll grep for port again, and just do it star to start out with. You can see I have a number of directory things that we'll ignore, but it will also print out a whole bunch of different random occurrences of port. So let's say we only want the file name again, so we're going to say -L, and you can see there's just the file names there. Now I'm going to try and get rid of all this junk. It should be printing these things, these is directories, these kind of errors to standard error. So remember to redirect standard error. We could probably do this. Dev null. So all of those error outputs would just be ignored. Remember, we can redirect our standard out with just the single one, dev null. We could only get the errors if we wanted to. Or we can say 2 and then bracket thing, dev null, and that would redirect all the errors. So we could take this output, let's say we wanted to process each single file that contained an occurrence of port. We could capture this in a for loop and say for each item, and then process each file on its own. But the final thing we could do is we could recursively grep. So when we say -R, that will go through all of the subdirectories in that in our particular folder right now, and it will search everything, not just the current files. So you can see here, in addition to last time, we have these directories, so we've searched in all of the directories as well, which turns out there's quite a few occurrences of port in all of these things. So -R searches recursively down the entire directory tree that we are currently in. Next thing we're going to talk about is sed. So sed is a stream text editor kind of. So what sed will do is it will go line by line. It will apply your match. If your match is successful, it will process that match. So just as a really simple example, I have data here. So just a phone number, some phone numbers, and an email address. So let's say I wanted to delete this particular phone number from this text file. What I could do is say, we'll do it like this for now. We will pipe it through sed, and we can use our sed expression like this. So in the case of deleting, what we would do is we would say slash, we'll delete that 999 one right now. We'll put what text we want to delete, and then we say D at the very end. and now what would happen is you would get your new data after you had deleted that line. So by default, what sed does is it prints its output to the terminal. So in order to capture that, you'd have to redirect it with the redirection operator. Or if you didn't care about the original data, you know your stuff is correct, you could just say -e. So -e will modify the file itself immediately. So D is one of the things you could do with sed, but the more common thing that you can do with sed is substitute. So you put this D operator at the very end here to delete. If you put this S at the very beginning, you are in a substitution operation. So let's say you wanted to find this 9999 and replace it with redacted or something. And we put this final slash at the end. We would find the occurrence of this thing and we would replace it with the word redacted. So you could do that in any different thing. You could put a bunch of different things there that you wanted to. It's basically find and replace in the command line. From this standpoint, we're going to get into some more of the advanced usages of sed later on. I'm going to edit the data here. I want to show you this example. Let's say we had two occurrences of 9999 on the same line, and we wanted to work on both of those. So by default, in sed's default mode, you would only modify the first occurrence of something on a particular line. So we just replace the first occurrence of 9999. If we want to process all occurrences of particular data on a particular line, you would say G. So G stands for global. And now it would replace everything on that particular line. So the big thing to remember with using sed is it does process things line by line, so you can't have a match that goes over multiple lines. So I couldn't do something like 9999 and then new line 9999 to start matching the second one. That wouldn't work. Again, sed is only a line by line processor, so you can't do things like that. If you wanted to match multiple lines, you'd have to go and write some sort of program to do it, because there's no functionality to do it by default. So, talked about D, talked about G. The one other thing that's worth noting with sed is these separator things right here. So these slashes are completely optional to use that character. You can actually use a number of different characters. So all it matters is that you start off with the same separator and continue using that separator throughout. So let's say I had some data that contains slashes. Here, we'll do this. Well, let's look at our file names. We had that example from before. So we'll grep for port, and we will type it into sed. And let's say I want, I'm doing just directory name or file names right now. So let's say I wanted to, I'll go back over to etc actually. So let's see what that gives us for output first. Let's see, we have a number of things. Let's say I only wanted to find this particular directory inside that output. So by default, if I did something like this, or I wanted to replace that directory or something like that, I would have to escape this. So a big thing in regular expressions is escaping. So I would have to say backslash and then this slash, because this slash has special meaning inside of this expression. I have to do this again. Sed s, let's say, we can just do that. We'll just replace it with ASDF. So it would give us some error sort of like this if we accidentally used an escaped character, or a character that was supposed to be escaped inside that expression. So we'd have to say backslash slash again, and we can see we replace that one directory entry with ASDF. Now another way that we could go about doing this, other than escaping this forward slash is we could actually use different separator characters. So this is what I was kind of talking about before. So we could use like a pipe character instead. And as long as all of our separator characters are consistent, that's completely allowed. And we can see we didn't have to escape r slash at that point. So one thing that's kind of recommended that you do is that you use different separator characters if your data contains that character. So let's say you're working only with directory paths, file paths, things like that. You probably wouldn't want to use the forward slash as a separator for your replacement operation, because your data contains that, and you'd have to go through and you have to escape all of your data, which would just be super annoying. So that's that. Alright, so let's move on to full regular expressions then. So we've seen this a couple times. We have some problems with matching text. We don't necessarily want to match all, let's say in our SSH config, let's say we wanted to strip out all those comments. So we don't necessarily want to match, let's say, those pound signs inside our data. We only want to match them at the beginning of the line. So what regular expressions allow us to do is control where we're matching all of these different things. Let's say, I'll just give the basic example and then we'll run through this and we'll actually look at it a little bit more in depth. So by default, grep supports a few different regular expressions. If you're using more complex regular expressions that we get into in a bit here, you're probably going to want to use the -e mode. The -e puts it in extended regular expression mode, so you can specify a few different things. So maybe by default you want to just use -e if you're using regular expressions, but for now we're going to leave that off. So one of the most powerful things that we can do is say caret. So a caret in a regular expression means the beginning of the line. So let's say we want to only match beginning of the line, and we'll say sshd config. So this will only print comments at this point. So you can see we're matching that, but only at the beginning of the line. Of course, we can invert this with v, and it will only print lines which do not begin with that pound sign. So that's an interesting example. Another thing we could do is we could match the end of the line. So let's say we wanted to find only things that ended in 22. You could say 22 $, and $sign will match the end of the line. So in this case, we printed just port 22. I mean, doing this file normally, we could grep 22 and we would find that. So I'll make another file here, example, which has port 22, 22, 22 port. So by default, if we grepped for just 22, we would find all of those things. If we grepped beginning of line, grep beginning of line 22, example, we would find those occurrences, and if we grepped 22 end of line, we would find those occurrences. If we wanted to find only 22, we could say beginning of line and then end of line right away, and we would only have one occurrence of 22. So those are definitely super powerful and are worth knowing, I think. So we can go on to have a number of other operations. Let's say we wanted to match any word followed by any number. So we have a number of different things in our sshd config which start with a word and then have a number following. So word and then number. So we're going to print the entire thing. We're not going to print just the word or just the number. We're going to print anything that begins with a word and ends with a number. So there's a couple of different ways we do this. We're going to do this the hard way, I guess, to start out with. We're probably going to have to put grep in extended mode to allow us to do this. But we would say grep e, and what we would do is we could define a character class which would match words. So what a character class is 2 brackets. And we can put any characters that we want to match inside these brackets, and then we can process them. So let's say we wanted to okay, we'll do a more simple example first to start out with. Let's say we wanted to find anything that started with a P or a H. It would find everything that started at the beginning of the line that started with a P or an H. The important thing to remember is these are only single characters, so you can't put entire words in here, so you can't say something like this. In this case, it happens to give us what we wanted, but it matches this, it matches this, it matches this, it matches this. So we were going to try and find every single, let's just try and find every single word to start out with. So we can actually, instead of doing something like A, B, C, D, E, F, G, and typing out the entire thing, we can abbreviate that by saying A through Z, and then we can say also lowercase a through Z. And so what's going to happen right now, it's going to match any line that starts with any number of these letters, capital A through capital Z, or lowercase a through lowercase z. So we can see we're getting a little bit closer. So next thing that we can do is we can say we want to match any number of these characters. What that would essentially allow us to do is allow us to match the entire word. So we could say star, which stands for 0 or more. So star stands for 0 or more, so it would stand for 0 or more occurrences of any of these characters. So let's look at that. We're going to see interesting results, I think. So we can see we have this entire thing highlighted. But we also have all of these other comment lines highlighted. So when we're using star, star actually stands for 0 or more. So it actually allows us not to have any of these selected at all. So if we wanted to say 1 or more and require there to be at least one of these characters, we could say plus. So now that we're requiring at least one of these characters, we're going to see a little bit better there. Now, one of the things that I didn't account for is we actually have some numbers in our word here. So we could actually go back and we could change this up a little bit. Let's say we're going to say the other. So there's another actual meaning of this caret sign, and that's not. So when we're using it inside character classes, sorry, I need to move this up. When we're using our caret sign inside of a character class, we could actually say not, and then I'll say space. So this character class will match anything that is not a space, and will require it to be 1 or more time. So unfortunately, we matched our pound sign there. So perhaps a better way of doing it would be A through Z, 0 through 9. And then we have all of our things matched. All right, so again, we're trying to get to just numbers. So what I'm going to do is I'm going to put this in quotations so we can keep working on it. So what I'll do is I'll put a literal space right here, so there's actually a space here, and then we'll have another character class. We'll say 0 through 9, and we'll say plus, and that will match these numbers right here, again, requiring at least one occurrence of that number. And now we can see we have matched all of our SSH configuration directives that start with this command and have a number following them. So while this particular example isn't particularly useful, well, it's interesting to say the least, and you'll end up running into situations where you need to match data kind of fluidly like this, and this is the basis of how we would do that. So if we wanted to make this a little bit more rigorous, we could put this $sign at the end, and that would stop our match right there. So that's how we would get started. So with grep, there's also built-in like aliases for these kind of things. There's an alphanumeric alias. I don't remember it quite offhand. maybe it's in the sed page. I think I have it over here actually. Yeah. So you could say something like this alnum, and it would automatically do all of those things. So this would be the explicit way of doing it, and essentially what we just typed there would be expanded to this. Depending on what platform you're on, you might not actually have support for this. We'll see if I do right now. It's not space. Shouldn't need to use those double brackets there. And you could just define it like that instead of explicitly saying it out the entire way. So there's a number of different character classes you can actually use. This sheet just has them. Say all uppercase letters, lowercase, alpha, alpha num, digit, and so on and so forth. I mean, you can specify these things manually if you want to, A through Z, lowercase a through Z, and all of those type of things. But if you want just this alias, you can use those as well. Let's see if there's anything interesting here that I've been forgetting. This is also an interesting operator in regular expressions, this question mark. So a question mark allows something to optionally exist. So let's say we wanted to say we would like a number, but it's not necessarily required. We could put a question mark after that. These operations here. And it would optionally match that number. So you can see numbers are being matched here, but they're not being matched here. So that's kind of interesting. Let's say we had. We'll go over to some other data in a bit. So let's look at this thing we have over here, cat data. So I have again just these phone numbers here. So I just have them in a couple different forms. So let's write a little regular expression to match a phone number then. So doing this way would be pretty straightforward. But unfortunately we have a couple different ways that phone numbers can be represented. So let's just say rep e data will be our file. So we can say, again, we can do the character class. We can say 0 through 9. And we can actually specify a number of times for that to be repeated. So we could say curly bracket 3, which will match 3 occurrences of 0 through 9. So we can see we got a number of different matches here, but they're all 3 occurrences of 0 through 9. So we can continue to do that all out the entire way. We can say dash, and we can say 0 through 9 again, curly bracket 3 to repeat this character class 3 times, and then we can say 0 through 9 again, and then 3 times. 4 times for that final one. And that will match all phone numbers that are just hyphenated like that. Let's say we wanted to match that other one though. Let me see if I can do this. Okay, so we're going to look at another operator here, and that is the OR operator. So when we say a pipe, that is OR. So it will say any of these things here or any of these things following it. So we can actually define another regular expression to match the other form of the telephone numbers. So again, we're just doing this OR right here. So by default, we're just matching those numbers. We're going to say OR, and we're going to match the other form of the numbers. So normally we would just say parenthesis, but parenthesis actually has some special meaning in grep. Say group. We're going to talk about that in a little bit. So we need to say backslash parenthesis in order to escape that parenthesis. So we would say character class. Well, let's just match it really quick here. So we can see right now we're matching any of these numbers, or we're matching this opening parenthesis here. So we could say 0 through 9 again. We could say 3 times, just like before. We close it with a parenthesis. You can see we're starting to match that. And space, 0 through 9 again. 3 times. Dash, 0 through 9 again. And then 4 times. So now we're matching both forms of phone numbers. So there's another form that I forgot to put on here, the kind of the international way of doing things. So you'd have the country code, and then you'd have 999, 999, 9999, 9. How many do I have here? 1, 2, 3, 1, 2, 3, 1, 2, 3. I'm just going to retype it again because I don't know how many 9s I have. We'll do it 1, 2, 3 instead. 1, 2, 3, 1, 2, 3, 1, 2, 3, 4. There we go. So the thing that's a little bit tricky about this is country codes can be multiple digits. So you could have a 10 or 11 digit phone number. So one would be the US country code. We could have something like 40 or something like that for some super backwater country. I don't want to insult country number 40 or anything, but they're not first in the list. So we could also continue to write our regular expression just by default. Let's just say 10 digits. So 0 through 9. We're going to unfortunately hit the end of the line, I think, and we'll say 10 times. 11 times, sorry. 10 is a normal phone number, 11 is the international phone number. So we could say 11, or we could also probably say, we could do something like this. We could say 11 or 12, and it would allow us 11 occurrences of digits, or so a plus followed by 11 digits, or 12 followed by 11 digits. So there you go. You got a bunch of different regular expressions to match phone numbers. So one thing that you'll notice about regular expressions, this wasn't even a particularly complex example. You probably sit down and you could write this from memory, hopefully. That's the objective, is to be able to write this from memory, this type of regular expression. But you can see, like, just sitting down, if you were given this regular expression, it would take you a minute to figure out what it's doing. So regular expressions aren't really designed necessarily to be human readable, and you'll find that if you're trying to understand a regular expression, it's probably harder than actually just writing it yourself. So let's say I wanted to find a regular expression to match IP addresses. So I just say regex to match IP addresses. Let's search for that. Of course, where's my Stack Overflow post? So you would immediately look down, you'd look and you would see something kind of like this. And you'd be like, oh my goodness, what in the world is going on there? So when you're working with regular expressions, let's say you're trying to find IP addresses, you're trying to find a number of different things, there's probably more rules than you actually thought about when you started out with. So there's a number of different rules that apply to IP addresses. I mean, you can kind of look at this right here. You can say 255, 0 through 5. Unfortunately, with regular expressions, you can't count like an entire number, so you can't say a number here between 0 and 255, so you have to go and actually look at 255, 200, and then they go and they do 0 or 1, and a bunch of other operations that are a little bit harder to understand here. But then basically what they do is they repeat it 4 times. So another fun one that you might not expect is how would you, well, we're gonna do this one first. Let's go back. Okay, so we got our regular expression there to match phone numbers. So the other piece of data I had in there was email addresses. So we could kind of take a heavy-handed approach to email addresses. I'm going to actually show you the real regular expression that people use to find email addresses, which is actually pretty complicated. But we could do something just like this. We could say, basically, anything. We're going to take kind of an easy approach to this. Anything that is, so start at the very beginning again, so beginning of line, and then anything that's not an @ sign. Let's say we just wanted to match all of the users in that, but eventually does contain an @ sign. So that would match the user. So one of the things we'll see in rules for email addresses is you could have things like periods, we could have things like numbers. So we're probably going to have to match everything. So I'm just going to say everything that's not an @ sign, and then go forward. An @ sign, let's say we wanted to match the domain separately. I could say everything that's not a period. A period actually has special meaning. We'll talk about that in a second. That would match the DSU. Then I would say the literal period, and then we just say everything until the end. So what an actual period means is any character. So we see it match that E right there. But if we wanted to do any character a number of times, we could do a plus. And there we go, we have the entire email address matched. So let's say I wanted to show that period again. So if I said just period, it's weird it applied it over all of the characters multiple times. Oh, because it matched. It matched. So here's what happened here, is it applied this regular expression multiple times on each line. So it applied it multiple times, so it matched that, matched that, matched that, matched that. So let's say I only wanted to match anything that started with, a line that started with any data. I could say beginning of line, period. What I could do, I believe, if I know what I'm talking about, that would remove empty lines. So that's a cool regex to know offhand. How do you remove empty lines from a file? Just say beginning of line, period, to match anything, which would give you all of the things that actually had data on them. But going back to this, again, what we're doing here for our email addresses is starting at the beginning of the line, or matching anything that's not an @ sign one or more times. So we're going to require something to be before the @ sign. Let's do this. And then to match our domain name component separately, let's just do this even less heavy-handedly. Let's say after the @ sign, we're going to match dot plus. So Alex at Alex dot Alex, and that would be matched. And technically speaking, that's actually a valid email address, I think, but that's a little bit challenging. But if I wanted to do something like give it an invalid email address, something like that, that would not be matched because we're requiring, with the plus, one or more. So if we use star, again, remember star is 0 or more. So if I use star instead here, our regex wouldn't really work like we intended it to at all. And that would be matched because this original group right here, this character class, would never actually be required to match anything. So with that in mind, let's say regex to match email. So I think we're going to see something that's very similar to here, and they're going to be like, oh, you should probably use this because it's easy. So this is the per the RFC regex to match email addresses. So there's actually very, very specific and interesting rules as to what can actually be inside of an email address. So most of the time we're not going to want to do this. And yeah. So I think if we go down this post farther, we'll see somebody use something very similar to what we did. And they're just like, well, we don't want to write out that entire page of regexes, so we're going to kind of settle for this one. So this S here, we can look at that really quick. What does that actually do? So basically not white space. So anything, they're going to say anything that's not white space is allowed in the username component of the regular expression. We can replace, I'm just kind of just doing this. So they take a slightly different approach. So S plus should still match what we're trying to do. So that, again, just stands for anything that's not white space, one or more times, and then we're going to match up until that @ sign. So yeah, so regular expressions get to be quite complicated, but they're definitely worth knowing, I'd say. So the final thing we want to do is apply this to sed. So we kind of looked at searching with grep a little bit, but let's say we want to actually manipulate data. We want to, let's say, let's do a really simple example. Let's say we wanted to swap 2 words around. So I have echo word 1, 2. So let's say I had a file that had a bunch of, like a first word and a second word, and we wanted to swap those 2 things. We could actually do that with sed. And unfortunately, we're going to have to get into something called capture groups, which is going to be a little bit challenging, but we'll see what happens. So when we're doing capture groups in sed, or in regular expressions, a capture group is noted by parentheses. Farther down, I'm not going to get into this, we can actually use named capture groups, but by default, the first capture group we would see would be noted 1, second capture group we would see would be noted 2, and so on and so forth. So let's just do this right now. Let's specifically search and replace for 1. Now, normally we could do this. Let's say we wanted to replace 1, replace like that, and that would be the normal way of doing it. But let's just use capture groups right now to show how that would work. So I would say I have to escape slash. In this case, generally speaking, sed likes things to be escaped, capture groups at least. I could say 1. I think by default that will still work just the same. But then I could reference that capture group right here. So let's say I wanted to match it, but not do anything with it. I'd say /1, and it would just replace it with itself. So I don't actually have a good example for doing the replacement. But what we can do is we can reference that capture group. So instead of saying literal 1, we could say, like we saw before, that's /s for anything not white space. And we could say plus, we could say over here 1. Okay, so we have 1 word matched there. We have that matched in our first capture group. So then we would say, start our second capture group. We have this space here. We would say /s again plus, and we'd say /parenthesis and close that off. And then what we could do is we could say /2/1. And then not have it work at all, of course. Something happened here and I didn't actually match. So it's gonna, so sed's going, okay, maybe this S isn't supported in sed. So what I'm going to do instead is just use our character classes, say A through Z, plus A through Z plus. And we're still not quite getting it. Okay, I must have messed up somewhere here. You can see, I mean, if you're watching and you're looking at the syntax, like it's kind of hard to keep all of these things, keep track of all of these things. I'm having a few problems doing it. I think I might have to also escape these character class things. I don't know. Let's see what's going on here. 1. Okay, so we matched 1 successfully. Let's just say lowercase a through z for right now, plus. But that doesn't match successfully. Why is that? Try to escape that. Okay, so I guess instead we're gonna have. So that's one of the things is like you can use regular expressions in a bunch of different languages, but they all have different escaping rules and they're all quite odd. So I don't think you have to escape star. So yeah, you don't have to escape star, but you have to escape plus for some reason. So anyway, we're gonna get back to our original example. Sorry to get off on that as usual. So we're gonna say plus, then we're gonna say escape that slash. We're going to say A through Z again, escape the plus, escape the final closing slash, and then we'll say 2, and then we'll say 1, and hopefully everything will work out. And there we go. So we captured this right here. This is our first capture group right here. We would capture any word lowercase a through Z, we'd store it as group number 1. Here we'd capture again anything A through Z, and we'd store it as group number 2. And then we would replace that with group number 2 first, and then group number 1 second. So let's say we had some more. Let's actually make a data2 file 1, 2, and then let's say we just had another word, and that was just sitting in there. So by default, sed would actually, I believe, how am I going to do this? Print that second line, even though we might not want it to. So we could say cat data2, and it actually end up printing that second line, even though it didn't match any of our regular expression there. So one thing that we might want to do is turn on no print mode. So it would, by default, sed wouldn't print, and then we have to append this p onto the very end to actually get it to print. And that's what we would do if we had data that didn't match our form, but we wanted to match the regular expression, be replaced, and only print if it had a match. So that's one pretty simple example. Let's say we wanted to change the port on our SSH server programmatically. So what we could do is remember to change our port, we would have to change this 22 right here. So what we could do is, I'll just pipe it through for a little bit of ease. Say sed s. We could start our line port, and then we would capture dot star, so any character any number of times. Close off that parenthesis. So that entire group right there. And then what we would do, and I'll finish the line there just to make sure we are doing what we're thinking we're doing. And then we could say port 2222. Actually, we don't even need to capture in this case. We could just say port dot star, and then we could replace it with port 2222. I'll just search for port. You can see that we replaced it there. Let's redirect it into a file. New sshd config. And we'll open that up. And you can see we had programmatically changed our port number by matching that port directive and replacing it with 2222. So that's one of the biggest things we can do with sed is you'll have a configuration file. Maybe you're going to have a bunch of different configuration files that you need to modify quote-unquote programmatically. You don't want to go through by hand, open them all up in the editor and do that. Or let's say you're deploying something to a system and you need to edit those configurations programmatically. Sed is very good at doing that. The final thing that I'll say is we had this kind of way of doing things right now where we had standard in to sed redirected to a new file. The other way of doing things is actually we'll just work on this new sshd config and we'll write a slightly different one. We'll change, what will we change? We'll change, never mind, it's 1050, we'll call it good for today. But the final thing that I'd say is if you were just wanted to change this in one line, what you could do is say -e. So -e would actually modify this file directly in line. Or is it E? yeah, that's it for today. I'm going to figure this out. So, no, it's dash I. Just kidding. Lol, JK. Dash I would modify it inline. So, 1337. And there we got our 1337. Okay.